So in this video, we're actually going to figure out some equations for parabolas. So find the equation of a parabola with a vertex of 0, 0 and a focus of 3, 0. So let me start by just plotting these points. The vertex we said is here. I'm going to label that with a V. Sorry, it got so sloppy. And the focus is here. Label that with an F. Now, I want you to see that since I know the focus is to the right of the vertex, I know this parabola is doing this. Right? I know it's opening this way. So it is I'm just going to make this note over here. It is a y squared equals 4px. Right? It is one of these because it's opening sideways. Now that P, remember, is how far the focus is from the vertex. So you come down here and you say, well, they are 3 units apart, so that's my P value. So my final equation is y squared equals, well, maybe not my final, I'll write 3 first. So my final equation is 12x, like that. All right, let's do another. For the parabola, y squared equals 8x. Find the vertex, focus, directrix, and graph it. Okay? So let's start with the fact that we haven't done any shifting here. There's no like y plus, there's no x plus. The vertex is still at 0, 0. Okay, so I'm going to write that down. Okay. There's the vertex. I'll label that with a V. Since it's a y squared, I know it's opening side to side, and it's positive, right? Everything's positive, so I know it's going this way. So the thing I would look at, kind of using this formula, y squared equals 4px, is that 4p must be equal to 8, right? This number right here. So p is 2. So and remember, P stands for the distance between the vertex and the focus. So I go 2 units away. Here's my focus. Now my directrix is the same distance, but so let me write, I'm just going to make 2. The directrix is 2 units behind. And I'm going to put a line. The directrix then is x equals -2. Okay. Now I'm going to make a graph here, just maybe with a couple of points, and then just remind you what everything does now that we've actually made a graph. Let me just pick a point I think would be easy. So y squared equals 8x. Let's say x was 2. Okay. Then I'd have y squared equals 16. So that means y is plus or minus 4. So I could put these points on. I could say, well, 2, 4, and 2, -4. And then I could do something like that. Okay? So, if you remember what all this stuff does, if I pick any random point on my parabola, and I draw a line to the focus, and I draw a line to the directrix, these two things will be the same length. Okay, let's do another. Find the equation of a parabola with a vertex 0, 0, if its axis of symmetry is the y-axis. Okay, so vertex is still 0, 0, 0. The axis of symmetry. So that means the thing that would divide it in half is the axis. So if this thing divides it in half, it's once again going to be a sideways parabola. It's going to be either this way or this way. So I know it's going to be a y squared equals 4px. Now, the way to figure out what P is, of course, is use the point. So, I've got y squared, so 2 squared, equals 4px. All right. Now, here's what that means, because remember, P is like a distance, so it's really, the negative means it's to the left. It's the negative side. So 2 units away, so my focus is back here. Here's my focus. Okay. So then your directrix is here at x equals positive 2. So let's go back and write the final equation. I have a y squared equals 4 times p times x. There it is. Let's do some more. Okay, in this example, I wanted to talk about what happens when we shift the graph around a little bit. So, find the equation of a parabola with a vertex of negative 2, 3. So let me do that. Back 2, up 3. Here's my vertex. But the focus is 0, 3. So here's my focus. So I want you to see right away, that's 2 units. That's going to be that value we multiply by 4. It is sideways once again. Okay, it's obviously opening this way, so it's going to be a y squared. Okay, so I'm going to go up to here. Focus on the one that's y squared. So I've got y minus the y value of the vertex equals 4 times that distance, x minus the x value. So y minus 3, I forgot the squared, equals 8 times x plus 2. One more. Graph x squared plus 4x minus 4y. So here's what we got to do. You'll see it is an x squared, so we are going to use this one because there's no y squared in this. So I'm going to try and get the y's to the other side. Now you'll see I'm going to have to, because I want to condense this down to look something like this, I'm going to have to complete the square. Okay, so I could say x squared plus 4x. Let's complete the square. Remember, you do half of this, half of 4, and then square it. So half of 4 squared is 4, and you can't do it to one side unless you do it to the other. So now, the left side, I think, we designed that so it just collapses down to be x plus 2 squared. So now I know the shift in the x direction is back 2 units. The y looks a little different. I'm going to factor a 4 out of that. So it's y plus 1. So now I know the vertex is negative 2, negative 1. So the vertex is right there. And you'll see, right here, this 4a apparently is just 4. So that must mean the difference or the distance between the vertex and the focus is just 1 unit. And since it is an x squared, it's going to be 1 unit above right there. So I should label these. There's my vertex and there's my focus. Of course, the directrix would be 1 unit the other way. So there's your directrix at y equals negative 2. And we could plug in some points here to see what y is. Maybe an x of 0. So we'd have 4 equals 4 times y plus 1. So of course we need 1 to equal y plus 1, so y is 0. So when x is 0, y is 0 right there. And we have symmetry, so we can go to the other side and do that. All I just did there was to plot get 1 point, use symmetry, so I could also I could get a little more accurate graph. And remember, any point I pick on the parabola, if I draw a line to the focus, draw a line to the directrix, those two will be the same.